Agenda. In this short video, I'll discuss the following topics. Topic number 1, I'll discuss the following concept: combination versus permutations. A. How to group all the matter and all that doesn't matter. So actually there are two different types. Example of combination and formula. Example of permutation and formula. For combination, order doesn't matter. For permutation, order matters. Then I'll use Excel function to calculate combination and permutation. Topic number 2, calculate expect value or expect result when probability is given. Suppose we have 3 outcomes, we have 3 probability. So what is expect value? Topic number 3, basic relationship of probability. Complement of event. So we have an event, and what is complement? Union of 2 events, intersection of 2 events, mutually exclusive events, and other probability relationship. Here I show how to calculate factorial. Okay. On top right, I list the definition of factorial. Okay. Formula to calculate factorial. N exclamation mark equals n times n minus 1 times n minus 2 times, continue this way, times 3 times 2 times 5 times 1. Suppose it's 5. Okay. 5 times 4 times 3 times 2 times 1. Suppose it's 10. 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. Okay. And so if it's 0, it is defined as 1. Okay. So let's randomly choose a number. Suppose we choose 3. Okay, 3, 2, and 1. Okay. Then we need 3 to 1. So what is factorial? It's 3 times 2 times 1. Then it's 6. So actually product. So it's product everything together. So it's a 6. Okay, I'll make the formula available. So this is show formula. Okay, so this is we simply apply the formula directly. Okay, it is a little tedious. We add some numbers. Okay, so let's try another one. Suppose we calculate 5, right? So 5, 4, 3, 2, 1. So we have 5 numbers. Exact same thing. We type product and including everything. So this is, I'm going to use show formula, right? So it's product A2 to A4, we include 3 numbers, and the product we include 5 numbers. Okay. So actually we have a better Excel function. It's called equals FACT. We only enter 1 number. Suppose we're interested in 3. Now we got our result. Okay. This means we don't have to generate 3 numbers. Okay. And it is also true. You see, FACT factorial, because we're interested in the 5, so this is 5. Okay, so this is show formula. Show formula, so this cell, okay, it's 5. Okay, so I'll enter 6, 10, 12, and 15. So let's directly use this FACT function. Okay. So FACT, what is factorial of 6? Okay, 720. So let's get the formula. Okay, actually it's FACT 6. Okay, so let's copy both formula down. Okay. You see 6 is 720, 10, very big number, 12, 15 is a huge number. Okay. So this is how to calculate factorial. Okay, so let's try 0 equal FACT and 0. Okay, then it's 1. So this is our definition of this one. Topic number 1A, combination. For the combination, order does not matter. Okay. Assume we randomly choose 2 values from 3 values of 1, 2, and 3. One possible outcome is 1 and 2. Another possible outcome is 2 and 1. Because they have the same set of values, we treat them as one outcome. Formula for the combination is, because the textbook uses capital N, small n, it's difficult to talk. I use small r, okay? And so I use this one as an example. We choose 2 out of 3. In this case, capital N is 3. Small r is 2. So the numerator will have 3 factorial, 2 factorial, 3 minus 2. Okay, I'm going to use Excel to show you. I will show you 2 methods. Apply the formula directly and apply Excel-related function. Assume we have 3 types of fruits: apple, banana, and orange. We plan to choose 2 from those 3 types of fruits. What are possible unique combinations? Obviously, 1 apple plus 1 banana is the same as 1 banana plus 1 apple. This means order does not matter. Below, we list all possible outcomes. The first pair is apple-banana. The second pair is apple-orange. The third pair is banana-orange, and banana-apple continue this way. Since there are some duplicates, we need to remove them. For example, the first pair, apple and banana, is the same thing as the fourth pair, banana and apple. So we need to delete the fourth pair. Below, I list all possible duplicates. The fourth, fifth, and sixth are simply duplicates of first, second, and third pair. After we remove all the duplicates, we end up only 3 unique pairs: apple-banana, apple-orange, and banana-orange. Let's look at a very simple example. We have 3 possible values, 1, 2, and 3. We randomly choose 2 from those 3 values. What are possible unique combinations? Here I mention unique because order does not matter. First, so let's choose different combination without consider the order. The first pair is 1 and 2. So we randomly pick up 1 and 2. Then the next one possible outcome is 1 and 3. Also 2 and 3, 2 and 1, 3 and 1, and 3 and 2. Because order does not matter, okay? Then we consider order, okay? You see the first one, 1 and 2, and the number 4, 2 and 1, they are same thing. So we delete 2 and 1. I use red one to indicate. The second pair, 1 and 3, is the same as 3 and 1. So I delete another one. And the number 3, 2 and 3, is the same thing as 3 and 2. So the combination of choosing 2 from 3, we have 3 possible outcomes. Now let's use Excel to calculate combinations. Okay. First, we enter n is total number of objects. Okay, how many type of the fruits we have. And next one, and as we mentioned before, there are 3 fruits: apple, banana, and orange. R is number of objects we are going to choose. Okay, should it be objects? And according to our previous case, is 2. Okay. So this is 2 out of 3. When order does not matter, we use combinations. Equal CONBIN. Left parenthesis. Then we end. You see the first input is number. We enter 3. The second one is number chosen. So result is 3, exactly as our manually result. Okay, so let's use the show formula to look at the formula. It's COMBIN D2 D3. Okay, so this is number of unique combination choices, unique choices. Okay, so let's choose a set of N and R. Remember, N is total objects. R is how many we plan to choose from this N different objects. So 2 out of 5, 4 out of 6. So let's look at the first one. We just apply equal CONBIN. Number is 5, comma, we enter 2. In total, we have 10 unique combination. When order does not matter. So we copy the formula down. If 3 out of 10, we have 120 different choices. Okay. If we look at the formula, then we understand how to calculate the combinations. Topic number 1b, permutation. The definition of permutation is we plan to choose R items from N different items. For this case, order matters. For example, if we choose 2 items, the first pair is 1, 2, the second pair is 2, 1. 1, 2 and 2, 1, they are different. And the formula from the textbook is given below because it uses N, capital N, lowercase n. I use R. Okay, so when we calculate different combination when order matters for permutation, it is a ratio. The numerator is n factorial. Denominator is n minus r factorial. D. Excel function equals permut. Let's look at one simple example for permutation. Assume we have 3 employees or 3 very good employees. The company want to choose CEO and VP from them. What are possible choices? In total, we have 6 different combinations. And for example, the first pair, James is CEO, Mary is VP. The second pair, James is CEO, and Tom is VP. Then Mary, Tom, Mary, James, Tom, James, Tom, Mary. The first pair, James, Mary, and the fourth pair, Mary and James. We have the same 2 persons. However, they are different. For the first pair, James is the CEO. For the fourth pair, he is VP. Now, let's use Excel to calculate permutation. For the permutation, order does matter. And first, let's enter N. It's total objects, total number of objects. As our previous example, we have 3 employees. R is number of chosen, number of objects we plan to choose out of N. Use the same example, there are 2 positions, CEO and VP, 2 out of 3. We use permut. The first one is N, total numbers. The second one is small r. Okay. In total, we have 6 choices. We use the show formula to show the formula in C6. So permut. Okay. Now let's enter a set of N and R. Let's look at different result by using this Excel function. 2 out of 5, 2 out of 6, 3 out of 7, 10, 2, and 10, 3. Okay, equals permut. The first input is N, the second one is R. Okay, so 2 out of 5, we have 20 different results when order play a role. So let's use show formula. So this error messages mean there's no such name. Okay, should be SHOW formula. Left parenthesis, we enter D9. Okay, then we have our, then we copy the formula down. Then we copy the show formula down as well. So this is our final result. So let's make it bigger. So this is, we applied permut. For permutation, we can easily figure out the formula by using common sense. Assuming we have 10 items, okay, we plan to choose 3 out of them. Okay, so every time we choose 3. In this case, n equals 10 and r equals 3. Below, we use 3 over to represent our first, second, and last choices. The question is how many different combinations when order matters. For example, what order matters mean 1, 2, 3, 2, 1, 3, they are different. Step 1, for the first choice, we have 10 possible items, so it's 10. After we fill the first oval, we have 9 items left. Thus, for the second stage, we have 9 choices. Combine the first and the second step, in total, we have 90 different choices. Step 3, after fill the first 2 oval, we have 8 left. Applying the same logic, the total number of choices is 10 times 9 times 8 is 720. Recall, our formula is n factorial n minus r factorial. So the formula should be 10 factorial divided by 10 minus 3 factorial. Our answer is 10 times 9 times 8. It is equivalent to, for the denominator and the numerator, we times 7 factorial. So it is equals 10 factorial divided by 7 factorial. Then equals our formula. Topic number. Assume we have an possible scenario or outcome. Each scenario has its own probability, Pi. P stands for probability, and its corresponding value, xi. The formula to calculate expected value is given below. P1 times x1 plus P2 times x2 plus P3 times x3 plus until the last Pn times xi. Below is one example. Assume we have an investment opportunity with 3 possible outcomes: 20%, 5%, and a negative 10%, with 30%, 50%, and 20% probability. What is its expected value? We can think about 30% economy expanding, 50% we have a normal economy, and 20% economy is going down. What is the expected value of this investment opportunity? Here we are going to use Excel to calculate expected value. There are 3 possible, because there are only a few numbers, we simply enter our values. Okay. So this is probability. We have 3 probability. 30% and 50% and 20%. So let's make it bigger. So this is probability: 20%, 50%, and 30%, 50%, and 20%. And also the summation should be 1 because this is basic. So I'm going to make it show formula make it available. So it's summation from A4 to A6. So this is potential outcome. Okay, we can use XI. So this is PI. So the first one is 20%. The second one is 5%. If something bad thing happen, we are going to lose 10%. Okay. So the third column is PI times XI. So it's simply P1 times X1. Okay, I'm going to use show formula. So A4, P1, X1, P2, X2, P3, X3. We simply copy and paste, and we copy paste all the formula. Okay. The final, our expect X value is simply the summation of these three values. I should use summation of these three values. So show formula. Okay. So this means if we have three possible outcomes with 30%, 50%, and 20% probability, corresponding return is 20%. First case and 5% second case and negative 10% the third case or scenario. Okay. Our expected value is 6.5%.
Shutterstock Music.